So our focus in this class is how can our Agile teams use lean principles, lean practices to improve business value creation, reduce blockers, non-value adding steps from their processes so that we can deliver more with less effort. And we focus on things that would eventually generate value for our customers, also for our business. Sounds good? Let's move on. Okay. So our initial conversation, and a lot of our conversation would revolve around these 7 types of waste that we often see in a system. As we mentioned, lean extensively is about reducing waste from our processes so that we can generate more value, so that we can increase things that would deliver more value for our customers. So this is the lens that we're going to be using for majority of our conversation as we go. 7 types of waste, and they go by the acronym TIM Wood. I was running a class last week, and we had somebody in my class whose name was Tim Wood. I'm like, Tim, you're never going to forget these 7 types of waste. All right, so let's dive in. T in our Tim Wood acronym stands for
time,
transport. Now, a lot of these forms of waste sound very manufacturing-like because they came from Toyota. So they came from the manufacturing space. Just like Agile as methodology, as a way of working, as a way of thinking came from software development, lean as a methodology came from manufacturing. So a lot of these wastes are going to sound like manufacturing heavy, but we're going to understand what are the implications of these and what this specifically means in our IT context. Let's talk about transport. Transport refers to excessive movement of goods and services in a system. Excessive movement of goods and services in a system. So here's a question for Dave, if that's okay, Dave. Dave from Buffalo. Yeah. Dave, have you ever seen this happen? A product owner potentially wrote a user story or identified some requirement for a system, and a developer coded that story. So they wrote code for that specific requirement, but the developer did not understand that requirement clearly enough, so it did not pass the test. And then we had to go back to get clarity on what that requirement specifically was. And this cycle went back and forth a few times. Have you seen that happen?
A lot, yes.
How often? All the time, isn't it?
More often than you want to admit.
More
yes.
often than we want. And this is an example of transportation waste, this back and forth movement of work in a system. Because according to lean, work should be done right the first time. It should have been ideally done right the first time. Now that sounds kind of bizarre. How can we accomplish this every single time? How can we get things right the first time? And that's where another Japanese philosophy comes into play, which is called poka-yoke. Have you heard of poka-yoke before? Anybody said of poka-yoke as a term? No? This is a Japanese term, which in English translates to mistake proofing. Mistake proofing. Which basically refers to the idea that how can we make it difficult for our people to make mistakes? How do we make it difficult for our people to make mistakes? Let's take an example. If I send an email to John from California and I say, hey, John, I'm sending you this attachment, but I forget to attach that attachment. What does my email application do? It gives me a pop-up. And they're making it difficult for me to make a mistake. Puneet, have you ever tried to fill out an application form online where you fill that entire application form out and you hit submit and it gives you an error message? It says, hey, you missed out on those 3 cells up there. Have you seen that happen?
yes.
What is that? That's an example of mistake proofing. They are making it difficult for us as users to make mistakes. Now, how can we mistake proof that agile team process? Now, this is where strategies like definition of done come into play. Definition of ready come into play. Anybody's used definition of ready for a team? Okay, yes. Many of us. Let's hear from maybe Simone this time. Simone from Minnesota. Do you want to share what definition of ready means for your team and how it helps, Simone?
Well, definition of ready, when it comes to like a workflow, you have to get it done and ready, all ready to move to the next workflow. So it's like you model something and then your documentation, everything is ready for the person to build because they can look at your documentation and just jump into building it.
Exactly.
Or
so definition of
testing, ready for things, the next step. Sorry.
Spot on, right? So definition of ready is essentially a checklist that we can use to get to mark something ready to go into backlog or to go into a sprint. For example, for a story to go into a sprint, we want to make sure that these 6 things have been identified. We have a clear acceptance criteria. We have a wireframe identified. We have agreed on what some of our key outcomes are going to be. And then we put it into our sprint backlog, and that's when we take it into execution. You with me? Similarly, some events that further help with avoiding that transportation waste. A common event where we can often use this checklist is backlog refinement. Who's attended backlog refinement in real life? An effective backlog refinement. Cool, many of us. Maybe let's hear from Lee from St. Louis, Missouri. So, Lee, do you want to share what backlog refinement is and how do you think it helps?
So refinement is a review of stories. Sometimes those stories have already been created by others. Sometimes you create stories collaboratively with the team, and you come up with the description of the user story as far as what you need, any details you might need, and then the acceptance criteria. And a question I like to ask in refinement at the end of the story to help avoid transport waste is to just ask the team members, if you were committing to this story, is it ready for you to develop? And if the answer is no, then we've got some more work to do.
Spot on. So backlog refinement is essentially a proactive event, right? It is an event that we have in any given sprint to refine stories for future sprints, for future iterations. And the intent is exactly as Lee mentioned, reduce that transportation waste to increase our chances of getting things right the first time, right? So backlog refinement, definition of ready, those type of checklists would help us further optimize that, having good acceptance criteria for our stories. And that is where tools or templates like given, when, then acceptance criteria come. Anybody's used a given, when, then acceptance criteria? All right, many of us. Let's hear from maybe Nayana. Nayana, do you want to share what given, when, then acceptance criteria are and how they help?
Yeah, so generally, instead of approaching one feature as a whole, you divide it further. And then for each, say, scenario, you mention the scenario in the given part, say, given this is the background or this is the scenario. Then when, say, the user clicks a particular button, then as a result, this is supposed to happen, so that it's very clear that these are the steps, this is the background, and this is the outcome we are expecting, so that there's not much deviation from what we are expecting and what is finally being developed. So it does help.
Spot on. That's exactly what these given, when, then criteria are. Given, when, then criteria also are called Gherkin acceptance criteria, Gherkin style criteria, which came from this body of work called PDD, behavior driven development. And behavior driven development introduced this template of given, when, then criteria. And the reason for using this template is, number one, it forces us to be specific. on what we are looking to accomplish from a given functionality. And also when we have templates, would you agree when we have a template, life becomes easier? Right? So it gives us a template to guide our thinking. And another reason why we use this often is it can directly translate into automated tests. Have you heard of these tools like Selenium, Cucumber? Yeah, many of us. Now, Selenium, Cucumber, these are tools which work in collaboration for test automation purposes for our Agile teams. And they almost have 100% market share when it comes to test automation tools. Now, when you have to automate a test in a tool like Selenium or Cucumber, that tool asks you to supply the test in given, when, then format, which means if our acceptance criteria was already written using this format, that acceptance criteria can be directly transformed into our automated test cases, and we can generate test scripts for our work. With me so far? So definition of ready, backlog refinement, and finally another one that I earlier mentioned was definition of done, which is a similar concept as definition of ready. It is a checklist that the team agrees to. On, Chris, can we mute everybody? All right, Chris muted me as well. So here we go. So definition of done is a checklist to mark something done. So team agrees on how they would mark a story done, how they would mark a sprint done, how they could be ready for a release. So definition of done as a concept or as language, it came from tech teams, but essentially the concept can apply anywhere. For example, in my family, we have a definition of done for our day. Before we go to bed, we got to make sure that we've done these 7 things. That's all it is. It's a checklist to mark something done. For example, a team could have a definition of done for a sprint. Every time we complete a sprint, we're going to have these things checked off. All stories have passed our acceptance tests. All stories have been accepted by our product owner. Code has been checked into version control. Relevant documentation has been updated. All recurring tests have been stored under version control in this repository, and so on. Right? So that is a definition of done for a sprint that a team could agree on. Similarly, we could have definition of done for release. We could have definition of done to push code into production. We could have definition of done to mark a story. And those are some simple strategies that a team can agree on to proactively reduce that back and forth movement in a system. And with that, slowly, and this is not something that you optimize on overnight. It is an ongoing pursuit of optimization. We have to learn from our experience on an ongoing basis, see what's working, what's not working, and then in a retrospectives, we identify more areas of opportunity so that we can optimize our team's process. Hey, Jen. Jen's made it. Good to see you, Jen. Puneet is also here. Puneet and Jen. All right. So that is our transport waste. Good to move on. I refers to inventory. Now, what does inventory mean? Inventory means something in manufacturing, but we're going to understand what inventory means in our IT context. This is the most prevalent form of waste that we see in a system. In fact, we could do a full day training on how to reduce inventory waste in a team. It's so big. But we're going to scratch the surface of some of the key forms of inventory waste that we often see in our teams around us. Now, to first understand inventory waste, we got to understand inventory waste in other words, is also kind of like work in progress, which means anything that is in between trigger and the customer, in between a request and the customer, is what inventory in a system is. Now, to understand inventory, we'll take an example. First, we'll take a metaphorical example to understand this, and then we'll translate it into our IT terms. So I'm going to set some context, and then I'm going to ask you some questions. You want to pay attention to the context over here. Let's say we have a car wash shop. And in this car wash shop, we have 5 people that are washing cars. And these 5 people have to wash 5 cars. Once these 5 cars are washed, these cars go into a QA facility for some quick check, and then we give them to the customer. If the customer likes it, great. If they don't like it, we have to bring them back and we fix it again, wash it again, QA, customer. With me? 5 people, 5 cars, QA, customer. What are different ways these 5 people could wash these 5 cars? One common way that most people would think of is that each person over here starts washing 1 car. What's the WIP at that time? WIP is things that we have started, not finished. What's the WIP at that time? WIP becomes 5. Exactly. Thanks, Rick. So WIP becomes 5, which means each of those cars are in progress, and we have 5 people washing those cars in parallel, which also means that all of those cars are going to take a certain amount of time before they get done. And since we have equal capacity allocated to each car, 1 person is washing each car, each of those cars would get done approximately around the same time. You with me? Because we had equal capacity, so they should get done around the same, which means they go into QA as a batch of 5. Now they bottleneck the QA process. Do you see a lineup building up? So in our lean language, we say that a queue is starting to build up. You want to write this down? Queues build up when we have high WIP in a system. So that lineup is building up in our car wash shop for those cars move into the testing step. Are you with me? Now that lineup that often builds up, waiting for the next step, that queue that builds up, waiting for the next step, is also what we call inventory waste, which means mid-process work waiting for the next step. Mid-process work waiting for the next step. Question. Has anybody ever seen an Agile team or Scrum team, whatever you call it, where all the testing is done at the end of the sprint? Anybody seen one? Thumbs up if you've seen it. Yeah, seen an Agile team where testers are sitting idle in the beginning of the sprint? Developers are sitting idle at the end of the sprint? Is that starting to look a little bit like this car wash shop? Now, these type of Agile teams are given a funny name. What do we call them? Agile fall teams. Let me explain why. Let's say this is day 1 of a sprint. This is day 10 of a sprint. 10 working days in 2 weeks. So these are 10 days, day 1, day 10. Have you seen this kind of flow over the course of these 10 days? In the beginning of the sprint, they do all the design conversations, how we're going to execute these stories and so on. The majority of the sprint is dedicated towards development. Towards the end, they do all the testing. Have you seen this kind of flow? Do you see a mini waterfall project happening in these 2 weeks? Now, these teams are called Agile fall teams, and from a morale, burnout, predictability, and other ways, these teams often become even worse than waterfall. I'll explain why. Anybody here has been a tester, has a testing background, or worked closely with testers? Yeah, Chetan, Lee, Nayana, many of us, Susan, Puneet. Yeah, okay. So question for our testers in the room. What are the odds that some tests around the end of this sprint could fail? Can some tests fail? Yeah, okay. So if the tests fail at the end of the sprint, do we have time in the same sprint to go back and fix our work? No. If we don't fix our work, are we going to have a shippable build at the end of the sprint? No. Another team that was depending on us, are we going to be able to honor that dependency that another team had on our team? Likely not. And that ripple effect starts to extrapolate across the entire value stream, across the entire ecosystem. This team spills stories into the next sprint and the next sprint and the next sprint, and that ripple effect creates a total chaos. And then people say things like, we tried Agile, it does not work in our environment. Have you seen people say that? Because they totally burn out because of how this process is working. And this is a team that is basically trying to be Agile with a waterfall mindset. They're working like a waterfall team, but they are trying to constrain themselves in a 2-week sprint. Now, there's many ways that we can use to optimize these teams. One common way that would help us optimize a team like this is practices like test-driven development or behavior-driven development. Anybody's used TDD, BDD at work? TDD, BDD in real life? A little bit. Jen, yeah, do you want to give us a quick intro to what it is, Jen, and how it helps, or what you've heard about it, Jen?
So from what I've heard about it and the way we employed it in France was for the QA to essentially define how they would test something. And then occasionally some of the tests are written and run to fail in advance. And once the code is written and those tests stop failing.
Spot on. So we start with writing tests first, such that those tests are failing, and then we write the code. Anything to add, Sudhir?
Harry. So we'll discuss with all the team members and product owners the test cases. So if any test cases are missing, we will include the test cases and we will start developing our acceptance criteria and the code based on the test cases.
Spot on, spot on. So I'll give a slightly more elaborate version of this, but what Jen and Sudhir said is spot on. So our traditional systems development has worked like this. We have requirements, we write code, we test code. Is that how we've always done things? According to TDD, it is a flawed approach. Why? We catch defects at the end of the process. Now, on your first impression, you're like, when else are we going to catch defects? We got to first do the work, then we'll catch defects. Here's what TDD says. It says you have a requirement. You figure out the details of the requirement. You figure out how you test this requirement. You write the test case for this requirement. You still don't have the code. You with me? We're writing our test cases first. So we write the test case for the requirement. We figure out, we ideally automate those test cases if we can. And then we give those test scripts, those automated tests, which are called test scripts, to the developer when they start writing code for a given story. So if I'm a developer, I'm writing code or I'm about to write code for a story, I already have the test with me. I didn't write it, somebody else wrote it, but I can run it. Question: if I run test for a story, which I do not have code for yet, is the test going to pass or fail? The test is going to fail, exactly. And as Jen said, that's exactly the starting point that we look for. We want the tests to fail. And then we write just enough code to make our tests pass. So the crux of test-driven development is simply this: start with the test in mind. Test should be a leading thought and not an afterthought, which it historically has been in our systems development approaches. And what does this do? What is this approach of, as we also call it, shift testing left in the process, right? Because our work goes from idea to the customer. So we say we want to be able to shift testing left in this process. So what does this do? For a mature Agile team, when they start the sprint, in the beginning of the sprint, And over the course of the sprint, testers and developers work in pairs or in trios. And they start writing test cases on day one itself. And the developer writes code and they're consistently working in collaboration over the course of the sprint. And if you see the completion rate of stories for a good Agile team, now what does a complete story mean? Developed, tested, accepted by the product owner. If you see the completion rate for stories for a good Agile team, it looks something like this. This is day 1, this is day 10. As they start working, they complete a story by day 3, day 4. Then they complete more stories, they complete more stories, and they gradually complete stories over the course of the sprint. And an Agile fall team, they work, and towards the end, try to deliver all of those stories. If you look at work in progress for a mature Agile team, you will see that it's going to be much lower than an Agile fall team, because these teams start fewer things at a time. They get those two done, and then they start on the next set of priorities. So those type of practices often help us improve flow in a team. So mature Agile teams are meant to be working in collaboration, and that is why Scrum was named Scrum. Do we know Scrum? Where does the name Scrum come from? It comes from the sport of rugby, right? And the intent with naming it Scrum was that a good Agile team should be functioning like a rugby team and not a relay race team. Do we see a difference? Rugby versus relay race, right? You pass the baton and now I'm done. My job is over, right? But a rugby team collaborates all the way through. Give me 1 second, Chetan.
Yeah.
So rugby team collaborates all the way through that process, working in pairs or trios all the way through. Now, TDD, BDD, if you're wondering what's the difference, TDD was what was created earlier, and it was initially a process or a way of developing just for developers. So I still remember when I first used TDD back in 2009, I used to be a developer at Dell. When they implemented TDD, we would write unit tests, then we would write the code. Write unit tests, then we write the code. Write unit tests, then we write the code. BDD is the same idea, but a more elaborate version of it. We write tests for stories. We write tests for features first before we write code. With me so far? Let's go a little deeper into reducing WIP/inventory. And this is where practices like WIP limits would come into play. Now, what is a WIP limit? It is a practice that we use. Test case, develop, done. Something like that, or accepted by PO. Anybody's used WIP limits at work? WIP limits at work. Okay, let's hear from maybe Chetan this time. Chetan, do you want to give us an intro to what WIP limits are, how they help?
WIP limits, I have worked with my team using the Kanban framework. So where they are just bringing in the stories from the product backlog. And we have seen that like when there is a WIP particular limit, we see that like until the first work has been completed or the first story has been completed, the team does not work on the second story. So that was that we used to have a WIP limit kind of thing, like before it goes from the left hand side column to the right hand side column, you see that all the work pertaining to that CRD card has been completed, then only you go to the next particular card of the functionality.
Spot on, spot on. So the idea behind WIP is that we put a limit on the maximum number of items that we can have in any stage of our Kanban board. So here's a simple Kanban that I've drawn: ready, test cases, develop, done. Or in some of our traditionally working teams, you could have developed first and then they write test cases. If a team is doing true test-driven development, they might even consolidate both of these into one column. But the main idea here is this, that we put a limit on the maximum number of items that we have in progress at any given time in any of these columns of the Kanban. So for example, if this team agrees that the total of stories in between these two Kanban columns is going to be a maximum of 3, that means that as soon as we have 3 stories in any of these Kanban, or collectively, sometimes we can put WIP limits on each column, or we can put a consolidated WIP limit for 2 columns as well. So there's no specific rules on how it should be done. Many teams use a WIP limit per column. Some teams use it for the entire in progress section. I generally prefer the entire in progress section. Reason being, it helps us reduce the WIP in this entire team. So if we have a WIP limit of 3 over here, which means that as soon as there is 3 stories across these 2 columns, team cannot start the next one, which therefore forces them to collaborate on these 3 stories, move something out, and then they get to start the next one. Now, how do we come up with WIP limits, and what is the impact of WIP limits? Let's see. So let's go back to our car wash shop. Remember our car wash shop? 5 people, 5 cars, QA, customer. Earlier, each person started 1 car. Now this time we're going to go to the other extreme. Now, what's the other extreme going to be? These 5 people are going to jump on 1 car. Hypothetically, right? We're trying to understand the concept. Now, if they jump on 1 car at a time, what's the WIP at any given time? WIP is 1, which means if those 5 people know how to function as a team, that 1 car would get done in less time, which means it would go into QA as a batch of 1, and then it would go to the customer. Are we able to incorporate learnings from the first car into the next car? Now we can, because we're doing them in sequence, as opposed to earlier when we had all of those stories happening, or all of those cars happening at the same time. So are you starting to see the impact of reducing WIP in this team? Here's a summary statement that I invite you to write down. WIP limits, or reducing WIP, helps us improve flow and support continuous delivery of value. WIP limits help us improve flow and support continuous delivery of value. Now, when a team limits WIP, works on fewer stories at a time, what that means is those stories would likely get done earlier in the iteration. They would be able to test those stories earlier in the iteration. They would be able to get feedback from the product owner a little bit earlier in the iteration. And as they say in Little's Law, it would help improve predictability and stability of this specific team. Everybody with me on the concept of what WIP is and what WIP limits are? Before I'm going to highlight 2 more nuances around this. So how does this work? Number 1, WIP limits apply to increments of value, not to a task. What's the difference? Increment of value versus a task. Increment of value is something that your customer wants. For example, our customer wants a table on a page. Our customer wants the ability to create an account. Our customer wants the ability to download this report. That's an increment of value. What's a task? Generally, each increment of value has multiple tasks. For example, for this table to be shown on the website, we need to write a query. We need to integrate the API. We need to build the front end. We need to write these test cases. We need to be able to make sure that all the tables exist in our data and so on. You with me? On what tasks are and what increments. Increment is what a customer wants. Task is different steps that we would have to perform to get that increment of value to the customer. So these WIP limits apply to a increment of value, which means that our team members collaborate on fewer things at a time from an increment of value standpoint, which they would complete before they start the next one. Good? Make sense? Second thing, is there a formula to come up with WIP limits for a team? No, but there is guidance for it. Let's see what our guidance is. Anybody who is a Scrum Master for a team? Can you raise your hand if you're a Scrum Master? Okay, many of us. So maybe let's hear from Agilista. Agilista, is that your actual name? Oh, you're muted. You're muted.
No, I'm Nelly.
Nelly?
Yes.
Okay, Nelly. How many team members do you have in your team?
12.
12 team members. Okay, big team. So it's pushing, limits of what a good team size is, but we'll go with it. How many developers, how many testers?
I've got 3 testers.
And how many developers?
And let me see, 7.
7 developers. Okay, plus product owner plus yourself makes it 12. Okay, so big team, right? Now, depending on the nature of how this team operates and how their stories are, this Nelly might start with an initial WIP limit of 7, which is on average, there would be no more than 1 story in progress for every developer. Now, that is a very high WIP limit, but she has a big team, so that can be her initial starting point. So that's the guidance, that we start with the number of development specialists in the team. Chances are it's not going to disrupt the process of her team so much. Even if she looks at her previous iterations, she may not have had more than 7 or 8 or 9 stories in progress at any given time, or maybe she did, right? So she starts with 7. She tracks velocity of that team for a couple sprints. And after a couple sprints, what is Nelly going to do? Nelly is going to say, okay, team, we're going to try a WIP limit of 5. Now there is 7 developers, 3 testers, and we're testing a WIP limit of 5. What is that gonna do? 7 developers, WIP limit of 5.
They'll have to pair.
What was that?
They'll have to pair.
Gretchen, what were you saying? You're muted, Gretchen.
It should increase efficiency, ideally.
It should increase efficiency. So it's going to force those developers to collaborate on those 5 stories, which means that those 5 stories would likely get done a little bit
faster
earlier in the iteration, which means they would be able to test and get feedback on those 5 stories a little bit earlier in the iteration. And in most scenarios, according to research, it would increase the velocity of this team. They would be able to increase their throughput and their velocity because it is going to improve utilization across the board. The testers would get involved earlier on. They would be able to get feedback sooner. They would have less surprises towards the end of our iteration. That is how work across this team would start to flow, as opposed to having those lineups build up over the course of our iteration. Thumbs up if this made sense. WIP is a tricky topic. There's a lot going on, and it's often counterintuitive for many people to understand how reducing WIP can help us improve our throughput in a given system. So that brings us back to our second form of waste, which was inventory. As we reduce WIP or inventory in a system, we're able to have our work flow more seamlessly. We get feedback sooner, and therefore that helps us improve reliability, predictability, and stability of our system. Yeah, Rick, did you have a comment, question?
Yeah, so it's something I put in the chat. It was interesting that you were suggesting that 5 people should wash one car. And I'm thinking, and that's so counterintuitive to what we're told in developing in like, C#, async await, spin off a task, let it run in the background, do other work. And the idea that, you want, in effect, more work in process in your running program, but not in the process of building the application. So it's very interesting, the contrast there.
I get it. And, and that is why we don't say that your WIP needs to be 1, right? That was just an example that we use to understand WIP, right? It doesn't necessarily have to be 1, because sometimes 1 is also not the most productive WIP limit. And that is why at no point we said your WIP limit needs to be 1. We said we need to control WIP in a system, and we need to test at what WIP limit we would be able to optimize our throughput for a given team.
And basically the idea is, if you can get actual testable stuff to a QA team within a few days, they're now busy working, you're continuing to do more development, they get more stuff, and it's more optimized because they spend a couple of days doing their tests, you do your 2 or 3 days developing your code, and everybody is then moving more efficiently than, like you said, the waterfall, big bang, dev team works for 8 days and then blast the QA guys.
Got it. Spot on.
Yeah, nice.
And also not use a mini waterfall approach either, right? So we want to start collaborating more over the course of the sprint. Yeah, Chetan, and then Jen.
Yeah, I have a question on that TDD slide which you showed just earlier. Yeah, I just wanted to know, like, as we are having only 2 weeks of a sprint cycle, and the developers are firefighting in completing the code. So generally, I have seen that some of the times or half of the time the developer says, hey, if we do TDD, we would be using more of our time first to write failed test cases, then to write past test cases. So can't we just, once the code is ready, so side by side we can write the code. So what is the benefit of TDD, like if there is a 2 week of a sprint cycle, and like first you write a failed test case and then the past test case?
It's not a failed test case and a past test case. It's only one test case, Chetan, and it's not written by the developer. It's written by a testing specialist who works with the developer. It's one test case that initially fails because we haven't written the code yet. The same test case passes because we do have the code written for that specific test case. So it's only one test case. It's not written by the developer. It's written by the tester on the team. Right? Okay, we want to use that as an input to have our developers know exactly what we want to build for. For example, if you're going to take an exam, it's like I give you the exam questions first, so that when you're preparing for the exam, you know what you need to be preparing for. Without preparation, you might fail that exam. With preparation, you would be able to pass the same exam. So it's the same test case that is initially failing, and then it can pass once the code has been written.
Only just one thing to add, like all our developers are itself a QA tester. We don't have a separate QA tester. So developers only write a code in Java in automated test cases and this everything as such, been a cross-functional kind of thing. So they used to say like, okay, we don't have a time because we also have to write the actual code. So hence, like, we don't want to go with the TDD as such. So that is the reason I just asked.
Yeah. Good. Yeah, Jen?
Sorry, it was just to jump off of what Rick had said. So agreed, we get more efficiencies when we have everyone working on something valuable and not people waiting for that baton to arrive to them. But that earlier feedback, getting an increment of value done sooner, the QA saying, hey, there's a defect here, allows the developer to actually fix that defect and thus release that increment of value. Whereas in waterfall, you sometimes get, the agile fall, you get to the end of your sprint and there's no time to fix those defects. And so we say, we're going to fix all our defects in the next sprint. And you come to your sprint review with not a conversation rather than something to actually show.
Spot on. Yeah, great. Good. So the goal is to reduce WIP, get feedback sooner, as we often say, shift testing left, learn faster so that we increase predictability in our process. And that is our second form of waste that we often have, which is our inventory waste. Ready for the third one? M refers to motion. Now, motion is, what is the difference between transport and motion? Now, the way Lean described these forms of waste, motion was referring to human motion, physical motion that people would often have to go through to be able to get something done. Now, there is no direct implication of motion or less direct implication of motion. Companies that focus a lot on motion waste are companies like McDonald's. I did a little bit of work with McDonald's back in my master's when I was in business school, and I learned that when McDonald's is designing their kitchens, they look at how many steps a specific team member in the kitchen has to take over the course of their shift. Because they have realized that if a team member in a kitchen has to take 2 steps to bring something from somewhere, to make a burger in the kitchen. Now, how many times are they going to take those 2 steps? Thousands of times over the course of the day. And sometimes what they have realized is that 1 or 2 steps in the kitchen can be the difference in between a profitable store or a not so profitable store, right? So that is what it means over there in manufacturing space, like how much movement do we require? And hence, often in Agile teams, we focus on co-located teams, bring them closer. Not only does it increase their collaboration, but also reduces motion waste in the system. Another way of looking at motion for our IT teams is what we call process motion, which means if I need something from IO is a part of our organization. Every few weeks, I have to go and get something or a specific data set that IO pulls from the database, and I have to raise a ticket. Then I have to go and look for somebody. Then this ticket gets assigned to IO. IO looks now, something that could have been done in a much simpler way is getting through multiple loops and hurdles. So that process motion is something that can often delay teams and our execution processes. And how do we mitigate this process motion? First, I'm going to show you one more example of how different types of processes could lead to forms of waste or waiting in a system. So here is an example, and this motion and waiting can go hand in hand. So W refers to waiting. Well, let you look at this example. And this is a slide that we often use in some of our SAFE courses as we go deeper into it. Now, maybe this is a slightly exaggerated scenario where 6 hours of value added work, so a little bit of work, is taking 7 weeks. Maybe this is exaggerated, but I'm sure we've seen some version of it in our organizations. Have you seen that? We do a little bit of work, then we have to email a supervisor, then we have to wait for an approval, then we have to wait for getting access to something, and so on. And what is happening? 1 day of work actually took 7 weeks. So flow efficiency is so low, only about 2%, right? So this process motion and waiting waste, which go hand in hand, can often reduce our flow in a given system. So how do we reduce motion waste in a system? This is where things like, we might have seen, and put it over here itself. This is where things like PI planning comes into play. Who's attended PI planning in real life? PI planning, yeah, what is PI planning? It is an event where multiple teams that are working on the same value stream get in the same room to build an aligned vision for their upcoming work. How often do we have things like PI planning? Generally, once every 3 months or once every 10 weeks or 8 weeks. So 8 to 12 is common for scaled agile organizations. Who attends PI planning? Business stakeholders, developers, testers, designers, architects, tech leads, security, compliance, scrum masters, product owners. Everybody gets in the same room to make quick decisions and align on their upcoming priorities. And sometimes people that are not as familiar with things like PI planning, and PI refers to that 10-week window, and they think, it's a lot of investment of time that we're putting in. Anybody's heard that concern about PI planning? 2 people are spending, or 100 people are spending 2 days in a meeting room. But what organizations have learned that perform PI planning consistently, they've learned that the cost, the price of doing PI planning is much lower than the cost of not doing PI planning, right? PI planning seems like big price tag. Oh yes, 100 people spending 2 days in a room. But what would happen if we do not do it? What's the cost of not doing it, right? We go back and forth, we're looking for people, we're not able to make decisions. What is the cost of misalignment? People not having clarity, not having clear dependencies identified, not being in sync with what our business priorities are. And that is why PI planning like events have become so popular for our organizations. So that is our motion waste. The W in Tim Wood stands for waiting, as I mentioned. Now, what causes waiting waste? Different things often cause waiting waste. You just saw that example over here. I did a lot of work with the US Air Force in 2015 and 16, helping them implement SAFe and LPM in many of their portfolios and agencies. And what I learned at the time was that for many of their teams and many of their initiatives, for any change they could accept in the backlog, they had to go through 25 plus approvals. 25 plus physical approvals would be put on a piece of paper before they could accept something in the backlog. And many of those approvals were rhetorical. And what I mean by that is that person is going to sign off if this person signs off. This person is going to sign off if this person signs off. You with me? Right? So truly, there is only 3 or 4 approvals, but we often have to go through those 25 plus approvals because that is how our processes work. So this is where things like, looking at our policies or practices that often slow things down comes into play. Can we reduce those 25 approvals to 7? Potentially, but it's going to require some rethinking on what approvals are critical, what approvals are just an overkill in our process. Right? Another way of reducing waiting waste is looking at redesigning our processes, which is where good conversations like retrospectives come in. For example, we just looked at that example of 2% flow efficiency. Remember that? Six hours of work taking 7 weeks. Now, how do we improve flow in those situations? There could be a scenario. I'm a developer on a team. I often need different types of data sets to run my tests. And every time I need a data set, let's say I need to reach out to Nancy to get that data set. What do I do when I reach out to Nancy? I have to send an email to Nancy. It takes me 5 minutes to send that email. That email goes into Nancy's inbox. Nancy picks up that request in a few days. Takes Nancy 10 minutes to get that data set over to me. You with me? So 10 minutes of work took us multiple days to turn around. What is our flow efficiency? Almost close to 0. right? 10 minutes of work is taking us multiple days. How can we improve flow in that situation? We can see, how can we give Harry access to some data set? Can Nancy create some self-service tools? Can we create an API library where people can start to self-service some of these requests? Can we send Harry to a training program to be able to pull data from this database using these pre-built queries so that we can reduce that dependency? Not only does it improve flow for Nancy's area when she's not juggling way too many tickets, it also improves flow in our team's context. Make sense? So waiting waste is reduced using those type of ongoing continuous improvement. Good system design also comes into play to improve waiting. Now, last week we had a webinar on demystifying DevOps. Anybody attended that last week's webinar on DevOps? So we're having these webinars every week. We had, yeah, PB, you were there too? Cool. Chetan was there, Nayana was there, Chi was there. Yeah, good. So we spoke a lot about good system design and how good system design helps us optimize flow in a team. So we're not going to go too deep into that, but the main idea that I'm going to enforce is what we call modular or microservice system design. Anybody's heard of modular architectures or microservice architecture? What does that mean? That we're breaking a large monolith into smaller microservices, which are loosely coupled with each other, and they can communicate with each other typically through REST APIs. Which means a team that's working on this specific microservice or this specific module of a system is freed up from dependencies from other parts of the system. A good metaphorical example of modular architecture that we discussed last week was our traditional computer systems. Anybody remember your first computer system that you bought? For me, it was an assembled system where I had to decide on what processor I want, what monitor I want, what memory I want, what CD-ROM I want, and so on. And it was assembled into a working solution. Now, that is an example of good architecture. Why? A team that's building the mouse can independently build the mouse. Do you see that? The team that's building the keyboard can independently build the keyboard. They are freed up from dependencies from other parts of the system or other teams that are working on the same value stream. Every team can release at their own pace. As an example, I've got a keyboard over here. You see my keyboard? Yeah, this keyboard is connected to a MacBook. Now, a team built this keyboard. If that team wants to release the next version of this keyboard and I'm ready to buy it, can I buy a newer version of the keyboard without changing the rest of my system? I can, right? Because of how this system is architected. This system has been architected in smaller modules. Now, if the laptop itself is not necessarily fully modular architecture because we cannot replace just the keyboard in the laptop, but it's modular for the teams that built. So they have built it in modules, but we get it as one monolith. So the key idea behind modular architecture is to free our teams up from dependencies. Now, the exact same phenomena that we discussed with computer systems applies to our software applications as well. It's just that we do not see it. It's not tangible to see, but behind the scenes, we can structure our systems in smaller modules or even smaller microservices, as we call them, so that our teams can be freed up from our dependencies. For example, Amazon.com is structured in 31,000 plus microservices. And they have mapped their teams to different microservices. As a result, those teams are able to release as fast as they want. Who knows how often Amazon's releasing, or make a guess?
Less than every 10 seconds.
Yeah, every 10, 11 seconds. Now, how are they able to do that? Primarily because of their system design. Now, it doesn't mean that every team is releasing every 11 seconds. It's just that some service is releasing at some point. It's like saying, globally, we have a flight taking off every second. Now, that doesn't mean it's happening in every airport. It just means that somewhere globally, a flight is taking off every second. So that's the same thing for Amazon. Some service is releasing at any given point. And they are able to release that frequently because of their system design. They have freed people up from dependencies. They don't have to wait on others to get their stuff done.
But they were originally a monolith.
What was that?
They were originally a monolith. They had to overhaul.
Absolutely. All right, let's move on with me on waiting waste. We got to reduce waiting time, remove those policies, practices, approvals, architecture approval, security approval on anything that we're going to do. Seen those things? Every story has to go through architecture approval before it can be developed. No. Those things often create a lot of waiting time. So let's go into our O. Ready for our O? The first O refers to over processing, which kind of goes hand in hand with many other forms of waste. Over processing, exactly what it sounds like. It's like overkilling something. 25 approvals to accept a change in the backlog. 25-page business cases to be written for every new initiative that we need to kick off. It has to go through this architecture review board every time we have to do something. Those are all examples of over processing or gold plating on a specific process. Do we want to eliminate documentation? No, but we want to reduce it to the minimum level that we need, depending on the context that we operate in. If you're in a public sector type regulated environment, you might have to align with more documentation as compared to if you are in a startup. So how much documentation do we need? As much as we think we would be able to use and generate some value. That's our over processing. Yeah, Vasant?
I have a question. It's waiting and over processing is kind of related, right? Because sometimes over processing can be a waiting scenario.
Over processing can cause waiting for sure. Yes, okay. Exactly. Okay. Totally. Okay. Okay. Yeah. Okay. Spot on. Good stuff. The second O is over production, which means producing more than what our systems can or what our customers can consume. Now we have less of this problem, in my biased opinion. We have a bigger problem of underproduction. We're not producing enough. We're not able to, meet our customer expectations or business expectations in terms of productivity and speed. But an example of overproduction sometimes could be what I've seen around me is, for example, managers receiving PDF reports. Most managers that I see around me, they receive more PDF reports in their inbox every day than they have the time or the desire to read. Anybody seen that? Way too many PDF reports being sent out. And sometimes one PDF report does not match the information presented in another PDF report on the same data set. Anybody seen that happen? Right? So overproduction is about producing things which our customers are maybe not using. So what do we need to do? We need to retire legacy applications. We need to look at how our customers' needs have changed over a period of time. Is our backlog still relevant to what we initially thought? Do we agree that business needs, customer needs are evolving at a very fast pace, especially right now in technology, right? Which means our backlogs have to consistently evolve. what is really important to a customer right now might not stay important 4 months from now, 6 months from now. And we would have to relook at how those things are changing so that we can deliver things that actually are valuable to our customers. Good. Ready for the last one? D refers to defects. Now, defects are pretty self-explaining. Anything that does not meet the quality criteria or the customer expectation on its first try. What helps us minimize defects? What helps us avoid defects? What helps us detect defects if they happen earlier in the process? Many things, many that we already touched on over here. Remember that? Definition of ready, backlog refinement, all those things would help us eventually improve our level of quality across the system. But other things that also help are automation. Right? Automation, or test automation more specifically, is going to help us catch defects earlier on in the process. I'll give you an example. We implemented continuous integration. Have you heard of CI/CD? Continuous integration, continuous deployment. So we implemented continuous integration for one of our clients, which is a bank based out of Toronto. And now it took us about 6 to 8 months to implement all of that advanced infrastructure, tools, and automate a number of different processes. But now developers in that specific bank, when they check out for their end of the day, if they have written code for a specific story, they check their code in. Overnight, a suite of automated tests and build processes run. And when they come back, they have feedback on how their code interacted with the rest of the system. And this continuous integration, or this integration and build, is happening in a staging environment. What is a staging environment? You know, the one before our production environment. Some people call it pre-production, same idea, right? So that automation can help us, number one, run those tests more frequently. If it's not automated, what's going to happen? We would be forced to defer. Have you seen people or teams, they write code for multiple sprints and then they integrate it? And sometimes they call it hardening sprint. Anybody's heard of this term, hardening sprint, right? Which basically, some companies use that slang, hardening sprint, which basically means that, oh, we're going to work for 3 sprints, and then in the 4th sprint, we try and integrate all of this code that we have written and see if it's actually working. And then they run into a bunch of bugs, defects, and they keep going around in circles. So this automation allows us to run those tests more frequently and get faster feedback. Good infrastructure, which means mimicking environments. For example, our dev environment to mimic our test environment to mimic our staging environment to mimic our production environment, which means the test data that we use. So these are technical practices, test data that we are using, how we're running our tests, our environments to be an image of each other. So that if a test passes in staging environment, we know that this code would work in production. Anybody seen that happen? It was working perfectly fine in our demo environment, in our staging environment, but did not work in production. Who's seen that happen? All the time, right? Which means that the staging environment was not a good representation of the production environment. So those are basic technical practices. We want to make sure our environments mimic. We use good test data so that we avoid catching issues towards the end of our process. So strategically working on these 7 types of waste. Now, later on, GE introduced another type of waste, so they made it 8, and that 8th one was waste of human skills. And what that meant was, if your people have skills that we're not able to consistently use to generate value for our business, then that is also a form of waste. But that was something that was added later on in the process. The original 7 form of wastes that created and represented lean mindset and lean methodology were these 7. So what is our implication from an agile team standpoint? Consistently evolving our mindset to be able to see wastes around you. Are you able to see one or multiple of these forms of waste in processes and teams around you? Thumbs up if you're able to see these. Right? So our goal is to first start seeing waste around us in these different forms and use retrospectives at the end of every sprint to identify those areas of opportunity. Keep an improvement backlog. Any Scrum Masters keeping an improvement backlog for your team? Improvement backlog. So that is a backlog that a Scrum Master should have, which creates a list of improvement items that you want to implement. For example, an improvement backlog item in your improvement backlog today could be, I want to help my team create a definition of done for a sprint. Then I want to help my team create definition of ready for a story. I want to help my team start evolving their infrastructure so that we can get closer to that microservice design. Right? So keep an improvement backlog, strategically address things in that backlog, and slowly we will be able to improve flow across our team's process and therefore generate more value for our customers and our business and deliver on our business priorities and goals. With this, we are done with our session for today.